On the morning of February 20th, 1943, north of Kasserine Pass in Tunisia, German tank commanders witnessed something that would haunt their understanding of warfare forever. Through the swirling dust and acrid smoke of the North African battlefield, 5 American Sherman tanks moved with an eerie coordination that defied every principle of Wehrmacht doctrine. These tanks, separated by broken terrain with no line of sight between them, converged on German positions with timing that seemed supernatural. There were no flags waving in the desert air, no colored flares arcing across the sky, no dispatch riders racing desperately between vehicles on motorcycles. Yet these metal beasts moved as if possessed by a single mind, each tank instinctively covering blind spots that others couldn't see, each crew somehow knowing exactly where their comrades were positioned in the chaos of battle. Meanwhile, inside their Panzer IVs equipped with state-of-the-art FUG-5 radios, German tank commanders struggled desperately to hear their own company leaders through static that overwhelmed their amplitude modulation systems like waves crashing over a seawall. The 10-watt German transmitters, considered cutting-edge technology by 1930 standards, couldn't penetrate more than a few hundred meters when tanks were moving across the battlefield. Most German tanks carried only receivers, leaving their crews unable to report what they saw or call for help when death approached through the desert haze. The Americans possessed technology that the Germans didn't even know existed. Every single Sherman tank operated with frequency modulation radios that provided crystal-controlled precision, 25 watts of transmission power, and clarity that cut through engine noise and battlefield chaos like a knife through paper. 8,000 miles from Detroit's bustling assembly lines, the most decisive technological advantage of World War II was revealing itself in the Tunisian desert. This advantage lay not in the thickness of armor plating or the caliber of main guns, but in the invisible electromagnetic waves that connected every American tank crew in ways the Wehrmacht had never imagined possible. The transformation that would reshape armored warfare forever had begun on July 22, 1941, when the United States Army standardized the Signal Corps radio sets SCR-508, SCR-528, and SCR-538 for all medium tanks. While German forces were advancing deep into the Soviet Union using tactics that depended on radio communication between command vehicles, American engineers at the Galvin Manufacturing Company, later known as Motorola, were perfecting frequency modulation technology that would render German communication systems obsolete. The engineering team included visionaries like Daniel E. Noble, who conceived the revolutionary application of FM technology in military vehicles, and Henryk Magnowski, the principal RF engineer who solved the complex technical challenges of installing sophisticated electronics in the harsh, vibrating environment of a combat tank. Their creation weighed 181 pounds and transformed every Sherman tank into a node in the world's first battlefield network. The BC-604 transmitter generated 25 watts of power, 2.5 times the output of Germany's FUG-5 system, operating in the 20.0 to 27.9 MHz frequency range. It provided 10 preset channels with crystal-controlled stability that maintained perfect clarity regardless of battlefield conditions. The dual BC-603 receivers in the SCR-508 allowed commanders to monitor multiple frequencies simultaneously, a capability that would prove absolutely decisive in the fluid, fast-moving battles ahead. The real revolution, however, lay in frequency modulation itself. Edwin Armstrong's FM technology, licensed to the military, eliminated the static and interference that plagued amplitude modulation systems like a plague. While German tank radios picked up every electrical discharge from spark plugs and motors as crackling noise, American FM radios delivered crystal-clear voice communication even during the most intense artillery barrages, when the very earth shook with explosive violence. On November 8, 1942, Operation Torch brought American armor to North Africa, and with it came the 2nd Armored Division's tanks landing near Safi and Fedala, each equipped with SCR-508 radios that would soon demonstrate their crushing superiority over German communications. The Africa Corps, despite being the Wehrmacht's most experienced and elite armored force, operated under severe communication limitations that would prove catastrophic. A standard German tank platoon of 5 vehicles included only 1 or 2 tanks with full FUG-5 transceivers capable of both transmitting and receiving messages. The remaining tanks carried FUG-2 receivers only, meaning they could hear orders but couldn't respond or report enemy positions they encountered. German tank platoons functioned through rigid hierarchy, with platoon leaders transmitting orders that subordinate tanks acknowledged through actions rather than words. When command tanks were destroyed, easily identified by their multiple antennas reaching toward the sky like metallic fingers, entire platoons lost coordination and became sitting targets. This vulnerability would prove catastrophic against American forces, where every single tank could assume command functions if needed. The Battle of Kasserine Pass, February 14 to 24, 1943, provided the first major demonstration of American radio superiority in actual combat conditions. Though tactically a German victory that sent American forces reeling backward, the battle revealed capabilities that stunned Wehrmacht observers who had never encountered such coordination. During the confused, swirling fighting across broken terrain, scattered elements of the U.S. 1st Armored Division maintained coordination across 50 miles of battlefield. Tank crews who had never met each other before coordinated complex attacks, warned each other of approaching threats, and called for devastating artillery support through crystal clear from communications that connected them like invisible threads. German signals intelligence units intercepted American transmissions and noted with growing alarm the exceptional clarity and coordination they witnessed. The 10th Panzer Division's intelligence section filed reports stating that American units maintained perfect communication at ranges where German radios produced only meaningless static. More disturbing still was the realization that every American tank appeared capable of full transmission capabilities, not just designated command vehicles, as German doctrine assumed. The German FUG-5 radios, operating on amplitude modulation in the 27.0 to 33.3 MHz range, suffered from fundamental limitations that no amount of tactical skill could overcome. The 10-watt transmitter struggled to reach 2 to 3 kilometers in ideal conditions, dropping to mere hundreds of meters when vehicles were moving across rough terrain. Every spark plug firing, every electrical motor spinning, every track movement generated interference that systems couldn't filter out, creating a constant background of crackling noise that drowned out vital communications. When American armor arrived in Italy in September 1943, mountainous terrain should have negated any radio advantages and leveled the playing field. Instead, FM technology proved even more valuable in conditions that rendered German radios completely useless. The SCR-508's frequency modulation handled the multipath interference of mountain valleys far better than amplitude modulation systems could manage. American tanks coordinated movements through terrain where visual signals were impossible and German radios failed completely. During the grueling advance toward Cassino, American armored units demonstrated capabilities that defied German understanding of tactical possibilities. Tank platoons separated by ridgelines coordinated precise attacks with timing that German doctrine insisted required visual contact between units. The 1st Armored Division's after-action reports described routine coordination at distances where German radios produced only static, leaving enemy commanders baffled by what seemed like telepathic communication. On June 6, 1944, as Sherman tanks rolled off landing craft at Normandy beaches under withering German fire, their SCR-508 radios maintained constant contact with naval fire support, enabling coordination that would have been impossible with German technology. However, the brutal hedgerow fighting that followed revealed a critical gap in American communications. Tank radios couldn't communicate with infantry radios operating on different frequencies, creating dangerous blind spots in coordination. The infantry's SCR-300 operated on 40.0 to 48.0 MHz, completely incompatible with tanks operating in the 20.0 to 27.9 MHz range. This communication gap proved deadly in the Bocage country, where German infantry armed with Panzerfaust could approach American tanks through the thick hedgerows while nearby American infantry had no way to warn the tank crews of approaching danger. American ingenuity solved this critical problem within weeks of identifying it. Tank crews began mounting EE-8 field telephones in ammunition boxes welded to tank exteriors, wired directly to internal communication systems. By Operation Cobra in late July, this simple, but brilliant modification had revolutionized tank infantry cooperation and eliminated a major vulnerability. Operation Cobra, July 25th to 30th, 1944, demonstrated the full devastating potential of American radio superiority when properly coordinated. The 2nd Armored Division, commanded by Major General Edward H. Brooks, coordinated over 200 Sherman tanks through radio networks that enabled unprecedented battlefield control and situational awareness. German defenders from the Panzer Lehr Division found themselves facing an enemy that seemed to possess supernatural awareness of every movement and threat. American tanks responded instantly to threats reported by other units miles away, while artillery strikes coordinated through tank radios arrived within minutes of target identification, raining death from the sky with terrifying precision. The contrast with German capabilities was stark and demoralizing. Panzer Lehr, once Germany's premier armored division and the pride of the Wehrmacht, had been reduced to communication poverty that left them fighting blind. Most tanks operated without radios at all, depending entirely on visual signals in terrain where visibility rarely exceeded 100 meters through the dust and smoke of battle. The few functioning radios suffered from interference and limited range that prevented effective coordination, leaving German tank commanders isolated and vulnerable. The irony was profound and bitter. Germany had pioneered radio use in armored warfare during the interwar years. Heinz Guderian, the brilliant architect of blitzkrieg tactics, had insisted on radio equipment in tanks since the 1920s, recognizing that rapid armored advances required reliable communication between units. His influential book, Acting Panzer, published in 1937, emphasized communication as absolutely essential to successful armored operations. Guderian had personally developed radio communication systems that enabled tank officers to coordinate complex attacks across wide frontages. He understood better than anyone that the lightning-fast armor advances that characterized blitzkrieg required reliable, instant communication between all units involved. Yet by 1943, German tank production couldn't provide the radios that Guderian's own doctrine demanded for victory. German production statistics revealed the depth of this crisis in stark, unforgiving numbers. In 1943 alone, Germany manufactured approximately 5,700 medium tanks rolling off production lines, but fewer than 2,000 FUG transceivers to equip them with communications. Many of these precious radios went to command vehicles and assault guns, leaving regular tank units desperately short of the communication equipment they needed to coordinate effectively in battle. Soviet tank forces suffered even worse communication poverty than their German enemies. The T-34, despite being the most produced Allied tank of the war with over 80,000 manufactured, typically entered combat without any radio equipment whatsoever. Soviet doctrine relied heavily on flag signals and pre-battle planning, with catastrophic results against German forces during the devastating defeats of 1941, when entire tank armies were destroyed due to poor coordination. By 1943, Lend-Lease provided some relief to Soviet forces. American radios, including SCR 508 sets, began equipping Soviet command tanks, but even by war's end, only about 25% of Soviet tanks carried any radio equipment at all. This comparison highlighted the magnitude of American achievement in communications. While the Soviet Union struggled to equip even 1/4 of their tanks with basic radios, America achieved 100% deployment of sophisticated FM systems across their entire armored force. Motorola's Chicago factory represented American industrial mobilization at its absolute peak efficiency. Before the war, the company had manufactured car radios for civilian automobiles. Converting to military production required complete retooling of assembly lines and solving unprecedented technical challenges that had never been attempted before. Each SCR 508 required 2,748 individual components manufactured to exacting military standards that tolerated no defects. The BC 604 transmitter alone contained 474 capacitors and 385 resistors, each precisely calibrated. Crystal oscillators had to maintain perfect frequency stability despite temperature extremes ranging from Arctic cold to desert heat, and the constant violent vibration of combat operations. Production statistics told the incredible story of American industrial might channeled toward victory. In 1942, Factories produced 3,800 SCR-508 family radios. By 1943, production had ramped up to 11,400 units rolling off assembly lines. In 1944, the peak year, 24,000 units were manufactured. Total wartime production exceeded 50,000 tank radio sets, a production miracle that ensured all 49,324 Sherman tanks manufactured during the war received sophisticated radio equipment. This was an achievement that no other nation even approached, much less matched. The SCR-508's advantages extended far beyond simple frequency modulation technology. Crystal-controlled frequency stability meant tanks could preset channels before battle and maintain perfect alignment despite the chaos and vibration of combat conditions. German FUG-5 radios, using variable capacitor tuning, constantly drifted off frequency, requiring constant manual adjustment that distracted crews from fighting. The dual receiver configuration allowed commanders to monitor their platoon net and company command net simultaneously, ensuring that orders flowed down the chain of command instantly while commanders maintained complete awareness of their subordinates' situations. The BC-606 intercom system integrated seamlessly with the radio equipment, allowing all crew members to instantly alert the commander to threats they spotted. Throat microphones and noise-canceling headphones enabled clear communication even during the loudest combat. When engines roared and guns thundered, many German tanks lacked intercoms entirely, forcing crews to communicate by touch or desperate shouting over the din of battle, creating dangerous delays in critical situations. Power management provided yet another crucial American advantage over German systems. The SCR-508 operated efficiently on either 12 or 24 volts, automatically adjusting to available power without requiring manual intervention. The dynamotor power supply provided stable, filtered power that eliminated electrical interference from the tank systems. German radios powered directly from vehicle electrical systems picked up every spark as crackling static that interfered with communications. The tactical advantages of universal radio deployment completely transformed American armor doctrine and operational capabilities. The combat command structure, which created flexible task forces organized for specific missions, depended entirely on reliable communications between all units involved. American commanders could create ad hoc battle groups from different units with complete confidence that they could coordinate effectively through their compatible radios. This operational flexibility completely baffled German commanders, who were accustomed to rigid organizational structures necessitated by their limited communications capabilities. During the Battle of Kasserine in September 1944, the 4th Armored Division faced multiple German panzer brigades equipped with superior Panther tanks that outgunned and outarmored the Shermans in every measurable category. The Germans possessed every conceivable advantage in armor thickness and firepower, but American radio coordination proved absolutely decisive in the outcome. Every Sherman could report enemy positions instantly to other units, creating a comprehensive picture of the battlefield. Tank destroyers received precise targeting information from tanks they couldn't see, allowing them to position for ambushes. Artillery observers in Sherman command tanks called in devastating barrage within minutes of identifying targets, raining destruction on German formations. Over 3 weeks of intense fighting, the 4th Armor destroyed 281 German armored vehicles while losing only 41 Shermans, achieving a remarkable 7-1 kill ratio that completely defied the technical specifications and theoretical advantages of German equipment. This lopsided victory demonstrated conclusively that coordination and communication superiority could overcome significant disadvantages in individual platform capabilities. Throughout the entire war, German intelligence consistently failed to grasp the true significance of American communication superiority, viewing it through the lens of their own limitations. Combat reports mentioned American coordination abilities, but German analysts attributed this coordination to superior training rather than technological advantages they couldn't imagine. A captured September 1944 intelligence assessment stated with complete misunderstanding, American tank units demonstrate good radio discipline and coordination. This appears to result from extensive training and rigid communication procedures. The report completely missed the fundamental technological advantage that made such coordination possible in the first place. German tactics never successfully adapted to counter American communication capabilities because they never fully understood what they were fighting against. They continued targeting supposed command tanks based on antenna configurations, not realizing that every Sherman could coordinate battlefield responses and assume command functions. They planned elaborate ambushes assuming American tanks would lose coordination when separated by terrain, never understanding that radio contact maintained unit cohesion regardless of visual contact between vehicles. In March 1945, as American forces approached the Rhine River for the final assault on Germany, their communication superiority reached its absolute zenith. The dramatic capture of the Remagen Bridge demonstrated the lightning speed of American command and control systems. When the 9th Armored Division discovered the Ludendorff Bridge still intact and undefended, radio reports reached 1st Army headquarters within minutes. Within a single hour, divisions across the entire front were shifting to exploit this unexpected opportunity, demonstrating coordination that German forces couldn't match. German forces, dependent on telephone lines that American aircraft had systematically destroyed throughout the campaign, couldn't respond with comparable speed to changing tactical situations. American radio coordination created an impenetrable defense of the bridgehead that German counterattacks couldn't penetrate. Tank platoons from different battalions integrated seamlessly into the defense, coordinating fires through radio networks that created overlapping fields of death. German counterattacks, poorly coordinated due to communication failures, arrived piecemeal and were systematically destroyed in detail by forces that seemed to anticipate every move. In April 1945, the encirclement of the Ruhr Pocket demonstrated the culmination of American communication superiority in what became known as the largest encirclement in military history. American armored columns from the 1st and 9th Armies coordinated a complex double envelopment entirely through radio communications, closing the trap around German forces with precision that seemed impossible. Inside the pocket, 325,000 German troops found themselves completely trapped, partly because their communications had collapsed under the weight of systematic American attacks on their command structure. American fighter-bombers, guided by radio-equipped forward air controllers, systematically destroyed German communication nodes with surgical precision. Wehrmacht units lost contact with higher headquarters and each other, leaving them fighting blind in isolated pockets. Field Marshal Walter Model's final messages before complete communication failure revealed the German plight in stark terms. No contact with adjacent units. No communication with higher headquarters. Fighting continues, but coordination impossible. These words epitomize the communication poverty that had doomed German forces. American radio superiority profoundly affected the psychological experience of tank warfare for crews on both sides. American tank crews fought with the constant knowledge that they were never truly alone, even when physically isolated by terrain or tactical circumstances. Radio waves connected them to their comrades, providing psychological comfort as well as tactical advantage. German tank crews experienced the opposite sensation, profound isolation that left them fighting individual battles within larger engagements they couldn't fully comprehend or influence. Otto Carius, one of Germany's most successful tank commanders, wrote in his memoir Tigers in the Mud about the constant challenges of limited communications, though he focused more on tactical aspects than the communication gap itself. The psychological impact of fighting without reliable communication created stress and uncertainty that affected German crew performance throughout the war. The strategic implications of American radio superiority extended far beyond individual battles to affect entire campaigns. American advances in 1944-45 maintained their devastating tempo partly through radio coordination that German forces simply couldn't match or counter effectively. Haddon's Third Army's legendary race across France depended entirely on radio networks that maintained command and control across hundreds of miles of rapidly changing front lines. German commanders consistently underestimated American operational capabilities because they couldn't conceive of the communication superiority that Americans possessed and took for granted. Heinz Guderian, serving in his role as Inspector General of Armored Troops, recognized the communication problem clearly, but couldn't solve it with Germany's limited industrial resources. In a prescient December 1944 memorandum, he acknowledged that American coordination capabilities negated German advantages in tank quality and firepower. But by then, it was far too late to address the fundamental deficiency that had plagued German forces throughout the war. After Germany's surrender in May 1945, American technical intelligence teams systematically evaluated captured German equipment to understand their adversaries' capabilities and limitations. Their findings confirmed what combat experience had already suggested through bitter fighting. German tanks often possessed superior armor and armament compared to American vehicles, but suffered from catastrophically inferior communications that negated their technical advantages. U.S. Army Technical Intelligence Report number 176 reached a damning conclusion about German radio technology. German tank communications equipment was approximately 5 years behind American systems in technological development. The absence of frequency modulation, limited radio distribution throughout units, and poor electrical suppression created critical vulnerabilities that could not be overcome through tactical skill alone. Soviet evaluators, given access to captured German equipment after the war, reached similar conclusions about German communication deficiencies. Remarkably, the Red Army chose to copy American radio designs rather than German systems for their post-war tank development, recognizing the superiority of FM technology over the IM systems Germany had relied upon throughout the conflict. Production and deployment statistics reveal the staggering magnitude of American achievement in tank communications. American forces produced over 50,000 SCR 508 by 528/538 radio units and manufactured 49,324 Sherman tanks, achieving 100% radio deployment across their entire armored force. Each radio transmitted 25 watts of power with crystal-controlled frequency stability of plus or minus 0.01%, providing reliable communication ranges of 7 miles while moving in 10 to 15 miles when stationary. In stark contrast, German production managed only approximately 6,000 FUG-5 transceivers for approximately 12,000 medium and heavy tanks produced during the war, achieving full transceiver deployment to only 20% of their armored vehicles. German radios transmitted only 10 watts of power with variable frequency stability of plus or minus 1%, limiting reliable communication to 0.5 to 1 mile while moving in 2 to 3 miles when stationary. Communication effectiveness statistics told an even more dramatic story. American forces averaged 3 to 5 minutes for fire missions from request to shells on target, while German forces required 15 to 30 minutes for the same coordination. 100% of American tanks achieved effective coordination through radio networks, while only 20% of German tanks possessed full communication capabilities. The radio superiority demonstrated by Sherman tanks established fundamental principles that continue to govern armored warfare in the modern era. Contemporary main battle tanks carry sophisticated communication suites that trace their technological lineage directly to the SCR 508, using digital rather than analog systems, but based on the same principle of universal deployment and reliable coordination between all units. The German Bundeswehr, rebuilt in the 1950s with American assistance, prioritized communications based on hard-learned World War II lessons about the consequences of communication poverty. Every Leopard tank manufactured since then has carried comprehensive radio systems as standard equipment. A Bundeswehr training manual explicitly acknowledges the historical lesson. The defeat of superior German tanks by inferior American vehicles with superior radios teaches that information dominance outweighs platform superiority in modern combat. Modern conflicts have repeatedly validated this fundamental lesson about the primacy of communications in armored warfare. During the 1991 Gulf War, coalition forces with superior communications systematically destroyed Iraqi forces equipped with individually superior Soviet-designed tanks that lacked effective radio coordination. In 2003, American forces again demonstrated that network-centric warfare defeats platform-centric warfare, regardless of individual vehicle capabilities. The story of American Sherman tank radio superiority represents a decisive victory in the electromagnetic spectrum that proved more crucial than any advantages in armor thickness or firepower. German tank crews fought their war partially blind to this revolution taking place around them, discovering too late that every Sherman tank was not merely a fighting vehicle, but a sophisticated node in history's first true battlefield network. The SCR 508 radio system transformed the M4 Sherman from an adequate medium tank into a vital component of a weapons system that included every other American tank on the battlefield. This transformation proved more decisive than any possible improvement in armor protection or firepower could have achieved, creating a force multiplication effect that German industry and doctrine couldn't match. Every Sherman tank carried the tools of ultimate victory, not just in its 75mm gun or sloped armor, but in the 181 pounds of radio equipment that connected its crew to every other American tank crew across the battlefield. This invisible connection created a form of collective intelligence that no individual German tank, regardless of its superiority in armor or firepower, could possibly match through isolated action. German forces discovered this harsh reality through bitter experience repeated across 3 continents. At Kasserine Pass in Tunisia's desert, in Italy's mountains, across France's hedgerow country, and in Germany's final desperate battles, American tanks demonstrated coordination capabilities that German doctrine insisted was impossible without visual contact between units. The Wehrmacht never developed an effective counter to this advantage because they never fully understood the technological foundation that made it possible. Field Marshal Wilhelm Keitel's reported comment at Germany's surrender captured this fundamental truth, whether the quote was accurately recorded or apocryphal. "We knew how to build better tanks, but you knew how to make them work together." America had constructed not just 49,324 individual Sherman tanks, but 49,324 interconnected nodes in the world's first armored battlefield network. The revolution in military affairs that modern historians identify with contemporary network-centric warfare actually began in 1942 when the first Sherman tank equipped with an SCR 508 radio entered combat in North Africa. From that pivotal moment, the nature of warfare changed forever according to a new paradigm. The side with superior communications would defeat the side with superior individual weapons. The network would triumph over the platform, and the connected would overcome the isolated, no matter how formidable individual enemy systems might appear. This profound transformation occurred largely invisible to German forces struggling to understand American tactical superiority. They witnessed the effects, but didn't recognize the technological foundation until far too late to develop effective countermeasures. By the time German commanders finally understood that every Sherman tank possessed communication capabilities that most German tanks completely lacked, the war's outcome was already decided by the invisible advantage they had failed to perceive or counter. The German military's failure to recognize and adapt to American communication superiority stands as one of World War II's greatest intelligence failures, with consequences that shaped the war's outcome. Despite countless battlefield encounters that demonstrated American coordination advantages, German leadership never prioritized solving their critical communication weakness that left their forces fighting blind. They continued building superior individual tanks that fought as isolated vehicles, while American forces built adequate tanks that fought as coordinated teams connected by invisible electromagnetic threads. In the final analysis, the electromagnetic waves carried by SCR 508 radios proved more powerful and decisive than the armor-piercing rounds fired by German 88mm guns. The ability to coordinate instantly, to share vital information across the battlefield, to fight as a unified force rather than as individual vehicles. This invisible advantage determined victory more surely than any visible superiority in armor protection or armament could have achieved. The Sherman tank's radio superiority changed the fundamental nature of warfare forever, establishing the enduring principle that in modern combat, connection equals survival while isolation equals certain defeat. German troops discovered this revolutionary truth on battlefields across 3 continents, learning too late that their American adversaries possessed not just numerical superiority in tanks and men, but crushing technological superiority in the dimension that mattered most: the ability to fight as one coordinated organism rather than as individual machines scattered across the battlefield, connected by nothing more than hope and courage in the face of an enemy that seemed to see and know everything.